All right, let's dive into something that is absolutely critical if you're building anything with large language models. We're talking about improper output handling. Seriously, if your app is using an LLM, you need to know this inside and out to keep it secure. So let's get right into it. To really get a handle on this, I want you to keep one simple idea in your head. Just picture your LLM as this incredibly smart, super fast intern. They're amazing, right? But they're also a bit naive. They can be tricked pretty easily, and sometimes they'll just confidently make stuff up. Your job is to be the manager who always checks their work. And that idea of checking the work brings us right to the official definition. This whole vulnerability happens when we, the managers, just fail to do that. It's when our application takes whatever our brilliant intern, the LLM, gives us and just runs with it. No questions asked, no double checking. And as you're about to see, that is a fantastically bad idea. So what really happens when we trust our intern a little too much? Well, there are people out there, malicious actors, just waiting to take advantage of that trust. Let's look at the exact ways they can fool our well-meaning but gullible LLM into causing some serious chaos. You know, the danger usually falls into a few common buckets. It's anytime the LLM's text output gets directly used to do something, like executing code, running a database query, rendering stuff on a web page, calling an external tool, or even making important business decisions. Each and every one of these is a doorway for an attacker. Let's kick things off with a total classic, just updated for the age of AI, SQL injection. So an attacker sends what looks like a normal request, maybe asking for information on a user named John. But look closely. Tacked onto the end is a nasty little command, and they're hoping our LLM just passes it right along. And our intern, the LLM, it's just trying to be helpful. It diligently combines the legit request with the malicious one, and it produces this single, absolutely devastating line of SQL code. It has no clue, zero idea that it was just tricked into writing a command to completely wipe out a database table. So what happens if our application blindly trusts that output? If it just runs it directly on the database? Boom, the user's table is gone, instantly, all because we didn't check our intern's work before letting it touch our production systems. Okay, let's move on to the next example and see how these attacks can get even more clever. In this case, a user asks the LLM to explain a simple piece of code. Seems harmless, right? But that little chunk of code is actually a malicious script, and it's designed to run inside another user's browser. So what does our helpful LLM do? It puts together a really nice-looking response, and just to be thorough, it includes the exact code it was asked about. It has no idea that a script tag isn't just plain text. To a web browser, that's an order to execute a command. Now, if our web app takes this HTML and just plops it onto the page for another user to see, their browser will do exactly what it's told, and it will execute that script. This is a classic cross-site scripting vulnerability, or XSS. And with it, attackers can steal user data, hijack sessions, all sorts of bad stuff. Okay, for our last example, let's imagine an LLM that's been given special powers or tools. Maybe it can send an email. An attacker can then craft a very specific prompt, basically telling the LLM to forget its original instructions and use that email tool for something sneaky. And the LLM, it just falls for the trick. It gets ready to call that send email tool, but just look at the details it's filled in. The to address, it's the attacker's, and the body, it's filled with sensitive user data that the attacker tricked the LLM into grabbing from the conversation. If the system is built to just automatically execute this tool call without any checks, that sensitive data is gone. Instantly exfiltrated, the LLM has just been turned into an insider threat, weaponized by a simple, tricky prompt. Now, you might be sitting there thinking, okay, these are kind of scary, but they're just made-up examples, right? Nope. Not at all. These exact kinds of vulnerabilities have been found and exploited in major real-world apps by security researchers and bug bounty hunters. This is happening right now. I mean, just look at the timeline. We've seen ChatGPT plugins get hijacked to steal data. Microsoft's Bing Chat was tricked into revealing its own internal system information. We've got research showing GitHub Copilot can be prompted to generate insecure code. The problem of blindly trusting LLM output is literally everywhere. So, the big question is, how do we fix this? How do we work safely with our brilliant but naive intern? Well, we need a plan. We need a manager's playbook, a clear set of rules so we can get all the amazing benefits of the LLM without any of these catastrophic risks. If you remember nothing else from this whole explainer, please burn this one rule into your brain. Treat all LLM output as untrusted user input. Every single character it generates should be treated with the same level of suspicion as if it came directly from an attacker. Never, ever trust it by default. Your playbook really has 6 key steps. 1. Validate the output. That's just checking your intern's work. 2. Use structured formats like JSON instead of letting it write raw code. Give it a template to fill out. 3. If you absolutely have to execute its output, do it in a sandbox, a safe, isolated play area where it can't do any real damage. 4. Encode any output that's going to a UI to neutralize scripts. 5. Use strict guardrails for tools. Only let the LLM use pre-approved, safe actions. And finally, number 6. For really sensitive stuff, require a human to sign off on it. And this slide right here just says it all. On the left, the bad way. We're just feeding the LLM's raw output straight to our database. That's a disaster waiting to happen. But on the right, we're being a good manager. We ask the LLM for structured data, like JSON, and then our own safe pre-written code builds the final query. We never let the intern write the actual code that goes to production. Okay, we have covered a lot, but I really want to leave you with one core mental model. A simple way of thinking that you can apply every single time you build an application that uses an LLM. The very first question you have to ask yourself is this. If a really clever attacker has total control over the input prompt, what's the absolute worst thing they could trick my LLM into saying? You got to think about malicious code, manipulated function calls, anything and everything. And that leads you right to the final, most critical question. What are the consequences if my system blindly trusts that worst-case output? That space, that gap between what the LLM could say and what your system can safely handle, that's where every single one of these vulnerabilities lives. Your job is to close that gap.